Hey guys, today is the review day for the test, so we're just going to go over some concepts that will definitely be on there. So let's go ahead and start with rewriting these into the other format. Let's pick a fun color here. Alright, so we have an equation that is in log form that we then need to convert to exponential form. So remember, you have to do the circle of life in this case. So we go from the base to the other side of the equal sign, and then that to the parentheses. So that gives us x to the y power equals z plus 2. Now don't get thrown off by the fact that there's more than one thing in these parentheses. It really doesn't matter. Whatever is in those parentheses is going to go in the position that it originally belongs to. Alright, so this is my answer. Okay, and another way you could remember it is that you know that like exponential form will always be kind of in this format, right? A number or something to an exponent equals something else. So when you follow this circle of life and you know to start at the base, then you just fill in these boxes in the order in which you hit things. So that's how we would know that it's going to look like this. All right, so now for this one, we need to convert to log form. We know that log form looks something like this. I just filled in some random variables in there like I've been doing. So remember that the base of the exponential function is also the base of the log. And the base of the exponential function is the thing being raised to an exponent. So we will put x plus 5 in the base of our log. I know it's weird to have something like that in the base, but that's all right. Just whatever is there goes in its spot. In the parentheses, we're going to put that a value for us, and that's always going to be what's on the other side of the equal sign. Okay, and then the exponent is always on the other side of the equal sign in our log. And if you're unsure of whether this is right or wrong, you can always test it out by doing your circle of life that you should know how to do and seeing if you get what you started with. So sure enough, when I did it, I got exactly what the original problem was, so that's how I know that I did it correctly. So this is my final answer. Ignore those arrows, that was just for my check. Alright, next we are going to write inverses of exponentials and logs. So if we start with an exponential, we know that our answer is going to end up being a log and vice versa. So let's recall the steps when we're finding the inverse of log and exponential functions. We start by switching x and y. And then we go ahead and convert to the other form. Nope. All right, so for this one, we have f of x equals 10 to the x. Remember that f of x you can just consider to be your y. So we have y equals 10 to the x. Step 1, switch x and y, so then we would have x equals 10 to the y. And then step 2 is to switch the format. So right now we're in exponential form, which is obvious because there's an exponent. So let's go ahead and put it in log form. We know that the base of our exponential is the base of our log, so in this case it's our 10. And this is what we end up with. And when you do this, you should always end up with y on this side of the equal sign when you're finding an inverse like that. So if you don't end up with y over here, that's your indicator that you did something incorrectly. So this is our final answer. Now for a log one, we know that we have y equals log base 5 of x. So step 1 is to switch x and y, which gives us x equals log base 5 of y. And then we can go ahead and rewrite this in the other form. Right now it's in log form because obviously the word log is in there. So we will go ahead and do the circle of life thing to put this in exponential form. Start at the base, go to other side of the equal sign, and then bring it back to the parentheses. That tells us it is 5 to the x equals y. So our final answer is just 5 to the x. All right. So if I now have a function that looks like this, it's not a log or an exponential, and there are two methods to do it. One is the list method, one is the switch and solve method. I will go ahead and just show you both so that you have both to work with and you can make the choice as to which one you like better. So first I'll start with the list method just because that's what we started first, that's what we learned first. So the first thing we want to do when we're doing the list method is to list out the operations going on in the original. So we can see that the first thing that happens to our x here is that we add 9. A lot of people on the last quiz wrote multiply by 2 first, but we have to see that the parentheses is always going to come first, right? We add 9 before that 2 is even involved. So step 1 is to add 9. Step 2 is to actually square this because now, again, when you think of your order of operations, we can see that exponent comes before multiplication. So we can say that we're squaring before we multiply by that 2. I know that 2 is really tempting, but we still need to ignore it for a little longer. So we're going to square things. Now that we've taken care of those pieces, we can go ahead and do the 2. Now multiplication is before addition. That's how we know that we need to take care of this 2 before I meant subtraction. We know we need to take care of this multiplication by 2 before we can focus on this minus 3. So multiply by 2. And then the last step is going to be that minus 3. So basically this is just that entire equation in English. So now that I have my first set of steps for the original equation, that's honestly the hardest part of this. The second part where we make the inverse one is the easier part, in my opinion. So we start at the bottom and we go up using the opposite operations each time. So we start by doing the opposite of this last step. So if we subtracted 3 before, we will add 3 for our first step here. Next comes the multiplication by 2, so the opposite of that is to divide by 2. Then it's squaring, so the opposite of squaring is square root. And lastly, we have add 9 at the top, so we're going to do the opposite, which is to subtract 9. So using this set of directions, we can now make our inverse function. And remember, I like to do that just by starting with, just a floating x. So just write an x, and we can then follow the steps. So step 1, add 3. Step 2, divide by 2. So we're going to divide everything here by 2. Step 3 is to square root. So everything here needs to be square rooted. And the last step is to subtract 9, so just on the outside here, we'll subtract 9 from everything we had. So this is my final answer. Technically, I should have that notation on the end there. All right, so that's the list method. Remember, the other way you can do it is the switch and solve method. So for that, we would switch x and y. Remember, the f of x is the y. So instead of y equals all of this, we will have x equals 2 times y plus 9 squared minus 3. And at that point, our goal is to just get y by itself. So we will start making moves to move everything away from y. The first thing we can move away is this 3. So because it's being subtracted, we can add it to both sides because we're maintaining that opposite rule. And basically, when we're solving this, you will find we're actually going to be following these steps. It's just that we might not have noticed that in the beginning. We ended up adding 3 first. Next, we can get rid of this 2. Until this 2 is gone, we cannot do anything in here. So let's divide by it because it's being multiplied right now. So those 2's will cancel. On the left, we have x plus 3 over 2. And on the right, we have our y plus 9 squared. All right, so we're still stuck in those parentheses. We want to get y alone, but we can't because there's a 9 and it's all being squared. So let's take care of that square root next, let's take care of that square next by square rooting both sides. So on the left, we will have the square root of x plus 3 over 2. And on the right, that square root will just cancel out the square, which is the whole reason we did it in the first place. So we're almost done. We just need to get y finally by itself now, and we're going to do that by getting rid of this 9. It's being added right now, so we'll do the opposite, which means we need to subtract it. We'll cancel on the right, and our final answer is x plus 3 over 2. Well, square root of that, minus 9. And that's a y there, but I'm going to replace it with my proper inverse notation. And you'll see that I ended up with the exact same answer as I did here. And again, the way we solved this equation was literally these steps in this order. So it ends up being the same process. All right, my last problem here is for graphs. And for this, you can always use your calculator to help you graph and get the table, or you can use your algebra skills and recognize that this is a mx plus b line. So, you know, our y-intercept is at 3, so we know it'll hit our graph at 3. And our slope is 3. We can consider that to be 3 over 1, so we'll go up 3 over 1. Again, I'm doing this with my, what I remember from algebra, but you can always use your calculator to help you graph this. All right, so we can go ahead and make our line through these points. All right, so that's my f of x. And we also want to do the inverse. A fast way to graph the inverse would be to just flip the points, right? You can pick any 2 points and flip-flop them, and that's enough for you to graph on My Open Math. So we can pick any. Well, let's go ahead and pick this one right over here. We have negative 1, 0, and this point we can do 0, 3. So from negative 1, 0, and 0, 3, the inverse versions of these would be 0, negative 1, and 3, 0. So these are the ones we would graph for the inverse. Okay, and on My Open Math, those are enough, and it'll just generate the line for you automatically. For me, I'm just going to fill in the rest of them so that I can get my graph. Because this is not My Open Math, it won't do it for me. Okay. And these are my 2 graphs, and I want to remind you that you can clearly tell that they're inverses because they are symmetrical across that line, that y equals x line that goes straight through the center. This is the one you will have to remember that you need in order to recognize if 2 graphs are inverses of each other. You can clearly see that the green and red are mirror images of each other across this particular line. All right, that is all for today.